Going on now to topic 4 of chapter 9, we're going to deal with properties of logarithmic functions. And we'll be looking at the logarithms of products, logarithms of powers, logarithms of quotients. Here, these are just going to be in a fraction form. And then we'll be using these properties together. Now, what I'm going to use a lot in this section are things from the PowerPoint slides. Again, what I did in preparing for this is I read the textbook and I looked at the PowerPoint presentation. And I saw there are a number of things that I could pick up and use from that would be useful. So let's look at our first one. Now, the first one we're going to look at is this one. And this is from previous sections way back there, where we are multiplying variables, again, the same base, but raising these variables to a power. Now the rule is if we had a to the second times a to the third, this would be a to the fifth. That is the rule, we just add our exponents. And adding of exponents is equivalent to multiplying variables with exponents. So this is something you should write in your notes as the basic rule for logarithms of products. Now I don't have a lot of room to write these out, so I'll use this little space up here. You're going to use your page over to the left in your booklet to write these out. So here we have this, and we want to write this so that it shows it as a sum of logarithms. And the way we do that, we go log base 3 of 3. Yeah, we get a phone call every once in a while. So we had log base 3 of 3. Now, since we're multiplying, we convert that to a plus. And then it's going to be this part again, log base 3 of 81. And that basically is converting this expression to the sum using the plus to indicate multiplication of exponents. Let's go on to 2. And here it's in the sum of logarithms form. We want to simplify that to a single logarithm. So it will be log base A, and then we're going to put as an intermediate step, since this is plus, it would indicate 10 times 6. Again, adding exponents implies multiplication, and then this will equal log base A of 60. Now for number 2, I'm going to a slide from our PowerPoint series. Remember, this is available to you online through my videos, or you could look at the PowerPoint in Math Lab as you would look at your textbook there as well. So the third property that we study is similar to the quotient rule for exponents. I'm getting ahead of myself a little bit. We want to do first, for example 2, the logarithms of powers. This again is a review of what we had earlier. That is, if we have a to the m, but now raised, because of the parentheses, to the power of n, what do we do in this situation? And the answer is we multiply our exponents. So let me show you an example of this. So if we had a to the third raised to the third power, what it means is a to the third times a to the third times a to the third. And we have to add now these exponents, and that would give us a to the ninth. But a shortcut, remember, of addition of the same things is to multiply. So 3 times 3 gives us a to the ninth. Okay? And that's what they're illustrating here. All right, now let's look at the rule. Now, the way this is handled when we use the power rule is we take the exponent and move it to the front of the logarithmic expression. So this will become -3, the exponent of our answer. That exponent is placed in the front of the logarithmic expression. And our answer is still put there. So this put into the power rule for logarithms, we take our exponent and simply put it in the front. Now for letter B, we have to modify that a little bit. I'll just put a little line to separate it. It's going to be log base 5. Now for the fourth root of a needs to be converted to a fractional exponent. This is from chapter 7, section 2. I remember it well. This becomes 1/4. So when we have it in radical form like this, in order to place it in this form, we have to convert the radical to its fractional exponential form. So now this is the exponent, which will go in front, log base 5 of a. So we're just taking these in little pieces and showing you how it works. Okay, now for example 3, we're going to use the equivalent expressions that are differences of logarithms. And I'll introduce that slide. Now all these rules that we are following are from earlier chapters. So we've had this before. This is the logarithms of quotients. And quotients, you recall, are fractions. And they are of this nature. So an example would be a to the 5th divided by a to the 2nd. We said we take the exponent from our smaller term, cross the division bar, and our exponent changes its sign. So in essence, what we're doing is subtracting. So where in multiplication, we added the exponents, in division, we're going to subtract exponents. And here is the rule. The n would come up, it changes signs, and we subtract. This is division. That is dividing this. So what we have in 3a is this. Now I don't like it written this way, I like it written this way. So what do we have here? Well, it will be log base m 10, and then since this is division, we're going to use subtraction, log base m L of L. And that is the answer to this one. So we'll pause, give you a chance to get it down, and we'll put letter B there. So as we write this in a single log form, it will be log base z, and then since this is subtraction, we know these items will be a quotient. And that's how you would write it. Because of this negative, it implies you're going to divide. Okay, let's go on to number 4. Now it says express as an equivalent expression using the individual logarithms of A, B, and C. Well, I think I have room here, so I will move this up. Now, as we look at this, this is a quotient, but some of these variables have exponents. So we'll do A first. Now it's going to be log base x, and it's going to be A there. Now, where are we going to put that exponent? We had done in an earlier example, we put it in front. The exponent goes in front, like so. Now, since these are division, we're going to use subtraction now of this first one, log base x of b, and here we have an exponent, so it's going to be negative 2. That is that exponent that's going to go out in front, log base x of c. Notice I'm writing smaller because I'm running out of room. Okay, so that's the first one. So once again, the log, as you start these, you have to start at a beginning. And what do? Well, I would put this down, log x. That's your basic thing that's going to appear throughout here. And then A is your answer. A has an exponent, so you put the exponent in front. And then this is division, a quotient, so this will be subtraction. All right, now let's do this one. Now here it's going to be, and again I have to fiddle with this a little bit, so I'll put it over here. So this is going to be log base y, and I'm going to convert this radical expression into a fractional exponent. So it's the square root of this. So what is the square root of something? Well, it's to the 1/2 power. And then this goes inside. A, b to the third, c. This in parentheses to our 1/2 power. So here when we write it, our exponent, which is 1/2 now, comes out here in front. And then we have to put a parenthesis because all of this is inside the parenthesis. So again, we have log base y. We're going to have 3 of those. So let me put them in here. Log base y, log base y. Again, I'm trying to show you a way to do it. So the first one we have is just going to be a right there. Now there's no exponent on a other than a 1, so where you could put a 1 there, you don't. So then now these are in the denominator, so we're going to have to put a minus sign now. This one has an exponent of 3, so we put that in front of our log, and then we put b there. This doesn't have an exponent, but it's in the denominator, so we just put a minus sign there, and our letter is C. So in a sense, I had some extra room there, so I can erase it way over there. Okay. Now again, the answers are all down below, so you can check them, but we want to show you how we got them and what we're doing. Okay, now they're asking us to express this as equivalent expressions in a single logarithm. So we're going to take this strung out version and put it into one of these. So let's see what we have. Well, our basic thing we're going to have is log base A. Now, one of these is a negative sign. So you know this is going to be in some sort of fraction, quotient form. And then we have x, this x right here, to the third power. We're taking the exponent from in front and putting it on the x value. And then down in our denominator, we're going to have the letter y. And there's a fourth power on that. So this 4, it's not a negative 4. The negative means it's going to be in the denominator, and it's going to be y to the 4th. Okay. Now here we have a plus. So that's back up in the numerator, and this is to the 1/2 power. So that's going to be the square root of z. And that is the answer to letter C. And hopefully one of the benefits of this is that you can rewind or go back in the video and see it again. All right, let's look at this one. Now notice it's log base A, and the square root of x over y. That's just this first part here. And since it's plus, this just goes up there. Now, theoretically, you could put this in front, but we can leave it like this. Now, can we do any canceling here? Yes, this y will cancel with this y. So we're now left with log base A of x, the square root of x. But that's not the answer they show down below. So let's show you how to get that answer. I'm going to just work with this part. This is x to the first times x to the 1/2 power. That's the square root of x is to the 1/2. Well, now we're going to add these exponents. We can't because this is not a denominator of 2. But what is 1? 1 is 2 over 2. So now this becomes x to the 3/2 power. And we can write in there log base a of x to the 3/2 power. And that's the answer they have down below. Now theoretically this would be a good one too, but I just wanted to show you how they got that. If I were giving a test and you wrote this, I would give you full credit for that. Let's go on. Now, what is mastery of this? And I've said this many times. You're going to be doing your practice and getting to know the skill of how to put it into MATLAB. And then you do your quiz me, and that is mastery. So that when you take your test, you are confident because you earned the right to do well on a test. Okay, let's check this out. Now we're going to be doing these. We're saying the logarithm base a of 3 is this. The log base a of 4 is this. Notice your bases are the same. Use these properties to calculate each of the following if it's possible. So we have here log, in fact let me write it up here. So log base a of 12, how could we use what we've just been going over to start to figure it? Well, this would be log base a of 12 is, I'm going to take this 12 and go 3 times 4. The 12 is 3 times 4. And this would be then the log of 3 plus, or base a, the log of 3, plus log base a of 4. Well, they give us the value of 3 here, and they give us the value of 4. So what do you think we're going to do here? Because again, this is log base a of 3 plus log base a of 4. Now, are we going to multiply these numbers or are we going to add them? And the answer is you're going to add them. So just add these two together and that is your answer. Now these are all down below. You want to be sure you know the method to get it. So what do you think we're going to do here? Well, 3, whatever that is, this, minus the 4. Where here we were adding because we're multiplying. Here we're going to subtract. So you're going to subtract this from that, and you're going to get a negative number, which is negative 0.147. Now in some of these they're a little tricky and you have to think about it a little bit, but again remembering the skills we had here. How about this one? Well, there's no 3 and 4 here, but look at this. This is 4 to the third power. And we know 4 to the third power. So that 3 is going to come out in front here. So we're actually going to do this. So here we're actually going to take this 4 up here and multiply it now by 3. Because we're raising an exponent to a power. Here's our exponent. We multiply it, and this is our answer for letter G. Now, there's another way to do it too, but I think this is the easiest. So let's look at this one now, letter H, and we'll clear it up a little bit too. Now here we have a 1 divided by 4. Now, we don't have a 1 up here, but let me just put it this way. 1, the logarithm of 1 is always 0. So you might add that to your notes. Anytime you have a 1, the logarithm of a 1 is 0. We had proved that in earlier lessons. So this is going to be 0 minus now, as we subtract that, the 4 value. And 0 minus this just gives you this as your answer for letter H. Now, this one's a little tricky, so let me set it up for you. So here it is in its spread out form that we're taking this. Remember, this is 3 times A. So it looks like this when we start. So what is our equivalent of the exponent for 3 here? And we say it's this. Now here we have our base A of A. And in one of our lessons we had said that whenever we see something like this part is actually a 1. That logarithm base A of A, where the letters are the same, or if this were 10 and this were 10, 3 and 3, the results would be a 1. So we take our 3 value, which is this, and we're going to add it to 1. So this gives us then as an answer 1.565, which is what they have down below for letter I. Now as we look at J, we have the log base A of 7. Now the factors of 7 are 1 times 7. But we don't have those up here. So for letter J, we just say cannot be found. Using these properties that they give us. Okay? So this again would be tricky if you had something like that and you didn't have a way to generate this. Now keep in mind you're going to be doing practice, but if you want to see more examples, look at the additional exercises where I worked through a lot of these. Okay. Now this next one, we're going to use a slide to show you this. And here's the slide. Now this is called the logarithm of the base to an exponent. So here's the general rule. For any base A, logarithm of base A, to the A power, which is what we just went over, raised to the K, Well, what is this part here? We said this part is a 1. So you're left with a k. And what does k equal? Well, it equals k. And the statement, the logarithm base a of a to an exponent is the exponent. The logarithm base a of a to the exponent is the exponent. This part is 1, so k equals k. So as long as you just remember this or write it down, this is going to be very useful. So as we look at these last few examples, we see log base 4 of 4. This is the exponent. So what does it equal? It equals the exponent. So when you see something where this and this are exactly the same, and it has an exponent, the answer is the exponent. So here we have 11, 11. This part is 1. So the exponent will equal the exponent. And here are our two answers. And that winds up this section. Under 32 minutes, a lot of good stuff going on here. You're going to do your practice and your quiz bees to get mastery.